Let's look at statistic and specifically empirical rule. So a sample of 1,500 mL is selected at random. For this sample, diastolic's blood pressure is normally distributed with a mean of 80, so that's the first information, and standard deviation of 10. The normal curve below shows the blood pressure of 1,500 mL in this sample. Okay, and we can see that normal distribution. Now, what do I need to know about it? Well, always remember that the area of the under the curve, first of all, adds up to 1, or we can say 100%. It is all probabilities. It's all of the possible outcome. Abilities. Yeah, so that's the idea of that curve. Now, first thing, what we need to do, fill in the missing numbers on the horizontal axis on the diagram above. And I know they didn't mention empirical rule, but they do in the next part use empirical rule, and that's how we know it is empirical rule we're going to use. So our mean is in the very middle here. Now, the problem with empirical rule is remembering the percentages. So if we go from the mean in both direction, one standard deviation, so in our case, minus 10 and plus 10. So the values we're going to have, we have 70, and here will be 90. This area under the curve, that is 68%. So that's difficult to remember, it's not in our table. Then if we go to standard deviation in both direction, so a further minus 10 and plus 10 from the mean, therefore the values on one side is 100 and on the other one is 60, that area here, that is my 95%. And yes, you guessed rightly, we go one more time with our standard deviation in both directions. So at this stage, I am 3 standard deviation away from the middle. So the two values will be 110 and 50. Now, that area, that is almost 100%, but not full 100%, is 99.7%. So a tiny, tiny bit, 0.3, which is actually 0.15 on both sides. Together they are 0.3. That's what is left. Okay, so we've done that part. Then the next one is saying use empirical rule or otherwise to find the approximate number. So the answer here, remember, empirical rule is about percentages, but here we are looking for a number of males. So if I'm thinking about percentage of a number, how do we do that? We multiply, isn't it? So how our males are here described? That in this sample have the blood pressure between 70 and 90. So that means 70 and 90, that's our one standard deviation about direction, and that is our 68%. So that's what I'm saying. Remembering that percentage is the difficult part. So therefore, we take 0.68, we multiply by 1,500, we put that in the calculator, we press equal, and we get is 1,020. Now, the last part is saying again use empirical rule to find approximate percentage. So here we are not going to be answering in numbers, but just percentage of males in the sample who have the blood pressure greater than 90. So what am I looking for here? So greater than 90. So this is where I have 90. So I am looking for this percentage here, that area. So how do I calculate? I'm just going to take that down here and draw it again. So I know that up to 80, that is half. That's my 50%. Okay, but what I need is actually here 90, isn't it? And still I'm going to put 80 here. What I actually need is this part here. So I know this is 50%. What is that part between 80 and 90? Between 80 and 90, that is half of what? 68%. So this part here is a half of 68%. Now, all of that area is what? 100% or 1. So if from 100% we take away 50% and we take away half of, meaning multiply by 68%, therefore we will be left over with that tiny area here. And again, if we put that in the calculator and press equal, we get that that is 16%.